Hello. So this back from the future to the annoying reality of daily life. This is the second half of the track user interfaces and user experiments. Our first speaker is Akito Uchiyama. I hope I pronounced it correctly. And he will talk about implementation of web-based operational log system at RIBF at the RIKEN Nishina Center. Please.
Okay. Thank you for your introduction. Good morning, everyone. Today, I'd like to talk about the implementation of a web-based operational log system at RIBF. So, this is the outline. First, I'd like to talk about overview of RIBF, and then control system for RIBF, and operational log system, and finally, summary. This slide shows about RIBF facility. RIBF factory, namely RIBF, it consists of 4 ring cyclotron, 2 linear accelerator, and ABF cyclotrons. This is the largest cyclotron facility in the world. There are 2 linear accelerators. This is Lilac and Lilac 2. There are 4 ring cyclotrons. SRC is a superconducting cyclotron in the world first. Variable heavy ion beams have been provided for experiment. We applied of new chemical element, nihonium, with atomic number of 113. It was discovered in this linear accelerator of RIBF project. This slide shows about control system for RIBF. EPIC system covers more than 1,000 power supplies of magnets, 400 beam diagnostic devices, and so on. EDM, MEDM, CS Studio, and LabVIEW are utilized for development of operator interface. EPIC offers not only remote control of these devices, but also other services, including data archiving system and operational log system, and so on. Next, I'd like to talk about the Zlog, which is developed by KK Control Group. Zlog is an operational log system based on ZOP. It also introduced in RIBF as well as JPAC and KKB. ZOP is a Python-based web application framework and web server. In backend, Postgres-based database and log monitor server are implemented. The log monitor server works as CA monitor coded in Python. In this system, one of the features is automatically operational log inserted by using CA monitor. This slide shows the user interface for Zlog. This is log viewer for KKB, like this. And this is the main web application for RIBF operational log, like this. In use of Zlog for RIBF, automatically inserted operational logs are often required. On the other hand, there is a little input comment because we have other log system. For example, a wiki-based system and paper-based logbook are also usually utilized comment writing still now. So, various kind of user interface is required for operational log system. So, we developed new RIBF operational log system. This slide shows about the system architecture. RIBF operational log is a compatible system with Zlog. It consists of web application, log monitor server, and database. About the database, it has same table structure with Zlog database. So Zlog web applications are also available to access RIBF operational log system database. we utilize PHP and jQuery for development of web application. In backend, Postgre-based database and log monitor server, and this log monitor server code in C language are implemented. Additionally, we use EPICS PV management system in order to make the list for 3,000 EPICS records. In this system, automatically inserted operational log is a comma separated character string. This is an example of user interface for electromagnet power supply operation. It has many functions for search the operational log. We can search the operational logs by device type, and we can search the operational log by time. And this application shows about maximum and minimum DAC values for 10 minutes. When click this hypertext link, all operational logs for this time range are displayed. This system also has a chart feature. When click here, chart feature is DAC operation is available. This chart feature is based on jQuery and JavaScript function. We can search by EPICS record. And when this search by EPICS record, we can use the autocomplete feature like this. Additionally, when click this button, it displays all latest operational logs as a list for specified day. So we can compare every previous parameter with current parameter, and it's very easy. This is the next example of user interface. This slide shows for wire scanner device operation for beam diagnostics. In this case, not only the operational log, but also measured data is displayed by image file. This slide shows about Faraday cap operation as beam diagnostics. Faraday cap operation monitoring is closely related to measurement of the beam service time. Therefore, we also implement another dedicated system. Beam status history is a visualization system for beam service time by using Faraday cap operational logs. Beam availability is an essential factor for performance of accelerator. Beam service time is measured automatically by beam status history system. As an event signal, for the cap status, this is set or out is utilized. The events are stored in the MySQL-based database. The web applications are developed with JavaScript chat library and jQuery. This is the same concept with Zlog. This slide shows about the user interface for beam status history. This is based on the Faraday cap operation. You can see the beam on-off status like this, and you can see the beam service time and beam on-off time like this. And you can see the input comment, but this input comment is not automatically inserted. Operator write these comments by hand. This is beam on time ratio. In this system, we can check the beam availability more easily than before. You can see the total beam service time for more easily for 1 day by bar chart. By input comment, you can see the ratio in causal beam off like this. So we can check the accelerator's condition more easily than before. It gets the keyword like this for beam stopping reason from input comment and make the list this chart. This is the result of implementation. To restore the previous parameter during beam tuning, the accelerator operator utilizes the RIBF operational log. It allows easy comparison of all path parameters, such as electromagnetic power supplies, with current parameter. When some trouble, the operator can restore the accelerator condition as soon as possible. When beam service time interruption occurs because of some trouble, the top priority is fixing the problem and providing the beam service time as soon as possible. So this system is very important. This is a summary. We have developed a new web-based RIBF operational log system, which is compatible with Zlog, based on requests from the RIBF accelerator operators. It has provided various user interfaces for the operational log. In the case of a problem during beam tuning, in particular, it is useful for analyzing and restoring. That's all. Thank you very much.
Thank you. We have time for 1 or 2 questions.
I had a question. Is ZOP still maintained? Is it still being developed, ZOP and Zlog? Is it still actively maintained, the product?
Yeah. In case of ZOP, we have to code by a web application. And I don't like this development environment. Okay. So I think it's easy to develop with PHP and compare with Python. So
Okay.